How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to enter our dynamic routing section by talking about RIP. So the Routing Information Protocol is where we are going to begin. So I'm going to go give you guys a high-level overview of how RIP works and all the good stuff that goes along with it. It's not a very complicated protocol to understand. It's just one of those ones where you might run into it in production, so I wanted to kind of give a high-level overview of how it works. Just like OSPF and EIGRP, RIP leverages multicast to discover other RIP speakers on a LAN segment. So a LAN segment is going to be any interface with a /30 or lower subnet mask and is also running RIP. So if I have R1 and R2 and they are both connected like so over 10.1.2.0/24, for example, you turn on RIP on the gig 0/0 interfaces, it's going to send RIP hellos out both interfaces. RIP uses 224.0.0.9 for its multicast address, which is referred to as link local multicast. So the multicast hellos that are sent out only have a TTL of 1. The time to live for the multicast packet is 1, which means it can be sent only this way and this way from each router. R1 sends to R2, R2 sends to R1, and that's as far as it goes. A TTL of 1 means that if I send traffic out gig 0/0 and it's received in gig 0/0, as soon as the receiving router receives it, it has to decrement the TTL by 1 hop every routed device that it passes through. So if you're already set to 1, that means you're the last hop that you can go. So this is an 8-bit field that is referenced. So what ends up happening is you are running RIP on the interface through the network statement, and then what you do is you use the network statement to enable RIP at the interface level, and then the interface will send out hellos to 224.0.9. It'll go both ways. The response will come back in, and you'll notice that it's not dynamic like EIGRP and OSPF, so you won't actually see a neighbor form. You'll have to do the show IP RIP neighbors and go about it that way. So you enable RIP globally, and then you enable the network statement, so specifically which interfaces are going to run RIP. And then once you do that, it's pretty straightforward. It goes out, it discovers neighbors, everybody's happy. Now, RIP's best path selection algorithm is based off of hop count. So, hop count. The Bellman-Ford algorithm is what RIP uses to determine who's doing what. RIP doesn't care about the link speed. It doesn't care about latency. It doesn't care about delay. None of these things are looked at. So all it looks at is hop count. That is it. This is your main thing. Hop count is the big thing you need to pay attention to. So, and part of the problem with RIP is that if you have, let's say you've got R1, R2, R3, R4, and there are LAN segments sitting behind R1 and R4, and you've got these connections going back and forth. If this is a 1 gig connection and this is a 10 gig connection, this is 1 and this is 10, RIP will load balance across both, because of the fact that the interfaces, the hop counts are the same. So you got 1 hop, 2 hops. So because R4's LAN segment is going to be 2 hops away, and RIP does support ECMP through multipathing, maximum paths, you're going to send traffic over both links. So RIP will do what EIGRP does, which is referred to as unequal cost load balancing. So that's essentially what RIP will do. Now, I'm not going to get into any more of the finite details of how RIP goes about doing. You can adjust it with offset lists and things like that. We're not going to get into any of that. I just want you to see how this process works. So now that we've talked about that, let us go ahead and actually go through and do a little bit of configuration. So I'm going to configure this between R21, R22, switch 2, and switch 1. Go ahead and get out of the way, pull up secure CRT. So on R21, I'm going to hit the enter key, go to global config, type in router RIP, and what we need to do, excuse me, you have a bunch of different options to enable RIP with. You can specify the address family and so on and so forth. We're just going to use a network statement. So we're going to type in do show IP interface brief. So we're going to type in network of 10.1.21.0 and hit the enter key. Now, if I do show run section RIP, you'll notice that RIP is enabled on all 10 network. So one of the things I have to do, if I type in do show IP RIP neighbor, what is the command? Show IP RIP neighbors database. So it's enabled on all the interfaces. That's okay in this particular case. But one of the things that I want to do is underneath router RIP, I want to type in here version 2. And what I'm going to go do is I'm going to go to router 22 and do the exact same thing. But if I do show run section RIP, the command still stays, right? The 10 network, it's always going to be a class full mapping. So it's going to, we're saying 10/8. So I'm going to go to R22, and I'm basically going to copy this config in there as well. We're going to copy paste that in just like so. We'll do that to switch 1 and switch 2 as well. So we'll knock that out real quick, just so you guys can see how this operates fully. All right, now I'll go back to R21. I'll jump out of global config and I'll do a show IP RIP neighbors. Nothing's showing up yet. We'll look at database. We have some stuff going back and forth, so we're starting to see. So the neighbors should start forming here soon. We can see database-wise, we can see what's going on. If we do a show IP route RIP, we can see we're learning some routes. Now the thing with RIP is it's a 30-second hello, and so eventually the traffic will age out. So this is not as robust as you would see if you were dealing with OSPF, EIGRP, IS to IS, stuff like that. So I've got my communication going back and forth. I can see R22 is available through both switch 1 and switch 2. We can see that right here, right there. And if we hit the up arrow, we're going to see that the hellos are going to go down. So they're coming down, they're going up, and then every 30 seconds you get a new table. So it'll continue to do that. Every 30 seconds there's a new update. So the routing table doesn't stay consistent all the time. So keep that in mind when you're looking at how RIP operates. So very straightforward for the most part. There's a few other things to take a look at. We can do authentication with it, so you can authenticate any of your RIP neighbors if you'd like to. If we were to go to the interface level and say interface gig 0/1, we can type in IP RIP, and then we can specify, for example, authentication, and we can support both keychains and MD5 authentication, stuff like that. I believe it'll support clear text. Yeah, it'll support MD5 and clear text authentication, stuff like that. Now if I do show run section RIP, and then go RIP, router RIP, I can do things like the neighbor statement, so I can form a unicast adjacency with the neighbor statement. If I wanted to mess with the timer, so timers, if I wanted to come here basic, and I wanted to set the interval to be 5 seconds, and then the invalid is at 10, something like that. The hold down is 180 or something like that. I can do that as well. If you want to know more about specific outputs, do a show IP protocols on here, and it'll tell you what they are. So right now we're not doing any filter lists anywhere, and we have updates are sent every 30 seconds. And then if you look, we have the invalid after 180, hold down is 180, and then flush after 240. So basically what you're going to do is if you don't hear anything for 3 minutes, so 6 intervals, you're going to hold down the routes, and then after 4 minutes, you're going to go ahead and just flush them. We can see that we are sending and receiving version 2 updates, and we're routing for this entire network. So very straightforward from an operational perspective. There's really not a whole lot to talk about with RIP. So the next thing I'm going to do is I'm going to go ahead and I'm going to create a default route, and the default route is going to point to R29 2.22.29.29, and what I'm going to do is I'm going to do a default information originate on R21 and R22 so that we each have a default route. So on R21, I'll go ahead and create an IP route, and I'll say 0.0.0.0 0.0.0.0 to 2.21.61.61 and hit the enter key. Now what I'll do, and one thing I want to point out is this static route is just a regular static route. There's nothing fancy about this guy. So what I could do is what they refer to as reliable static routing is I could create an IPSLA instance, we haven't talked about that yet, that will ping an IP address, and then we could tie that to a tracking object. The tracking object would then get tied to the static route. If the ping from the SLA operation were to ever stop receiving a response back from whatever we're pinging, for example, a gig 4's interface of gig 4 on R61, if I was to ping this IP address through an SLA instance, if that IP address was to stop responding, SLA fails, tracking fails. If the tracking fails, the static route fails. So what I'm going to go do here is I'm going to go and type in router rip, and I'm going to type in the command default dash information originate. And then if I wanted to, I could map a I could redistribute static if I wanted to, but since I have a default route, if I do show IP route, right, I have a default route in my routing table, I should actually get rid of some of these static routes that are here. So do show run type include IP route, and let's go ahead and get rid of a couple of these. These are from a video I was doing that I actually never moved forward with because I found a better way of explaining it elsewhere. Go ahead and get rid of some of these guys real quick. Okay, perfect. So do show IP route, so we can see the RIP routes that we've got. So I've done that. Now if I jump over here to switch 1 and I do show IP route, you'll notice that I get a default route. It's a RIP learned route, right? And notice that it's also got the star next to it, so it's a candidate default. When you see this, this means that I use the default information originate command to do it. So if I was to go back over here to say R22 and say IP route quad 0 to 2.22.29.29, and then go to router rip and type in redistribute static and set the metric to be, I'll say a 3, and hit the enter key, and then was to go over here to say switch 2 and do a show IP route. So we're getting the route from 22. I might have to, might take it a couple more minutes for it to propagate. I'm waiting for the next interval to come through. So show IP rip database. So we have the The route's coming through. It's auto summarized. Let's go back to 22. I also want to do, I want to say redistribute static with a metric of 3, but I want to do, actually I want to do it transparently. Transparent. That should give me the output that I'm looking for. There it goes. Now it's coming through. So if I do a show IP route, there we go. So I actually stand corrected. So the candidate default, it doesn't matter how it's redistributed, as long as it's there. So we see that we have a path where we got to go. So essentially what that does is, with having a default route on each one of the routers, so on R21, I am do show run section rip. By doing, I have a default route configured, and by doing the default information originate command, I'm saying R21, I want you to originate a default route to the rest of the RIP environment. And what that ends up doing is 21 propagates that to switch 2 and to switch 1. That gets the job done all day long. Everybody's happy. However, in that particular case, we're not doing a redistribution of a static route into RIP. We're telling RIP to propagate a default route for the rest of the RIP environment, and the other switches will get it. Now, what will end up happening is, operationally, whether you redistribute or you do the default information originate, it doesn't matter. They both get a RIP route propagated. Now, one thing I'm going to do real quick is on switch 1 and switch 2, if I do show IP interface brief, right? Do show IP interface brief. I don't have any SPIs created on switch 1 and switch 2 for any of these VLANs, right? So what I could do is I could create a couple of VLANs and advertise those into RIP. So what I'll do is I'll create do show VLAN brief. I have the VLANs here, so all I have to do is type in interface VLAN 1315, and that'll create the SPI. But if you'll notice that the SPI, as soon as you create it, it goes to administratively down. So that happens by default. So I had to type in IP address here will be 172.31.5. We'll say 11, because I know I don't, yeah, none of the PCs, PC4, PC40 something or other, what is that? 40. PC40, PC39, they don't have IP addresses yet. That'll be coming down the road when we get into things like DHCP. I'll be going through and configuring that type of stuff. So, I'll set the default gateway to be .254. I'll do a 1/24, and I'll type in no shut. And then I will go over to switch 2 and do the exact same thing. I'll go to global config, interface VLAN 1315. I'll put the IP address as 172.31.5.2/24. I'll no shut it. That brings up the IP address, or the SPI. And then what I'll do is router RIP, and I'll type in network of 172.31.0.0. And if I do show run section RIP, it'll show up as 172.31. Now, if I go over here to say router 21 and I hit the up arrow, or I go do show IP route, we'll see down at the bottom, we're going to see a 172.31/16. And one thing you got to keep in mind, in the back of your mind, whenever you're looking at RIP, it's classful. We have no way of differentiating. So this is one of the reasons why RIP is not very popular. It doesn't scale very well either. The other thing that with RIP is it's got a horrible hop count. The widest network you can build with RIP is 15 hops from end to end. Doesn't matter how cool you think you are, RIP has a hop count limit of 15. So because of that, you can't build a very large network. If you're going larger than 15, which I can't say most environments are even that big, but in this particular case, RIP is not built to be very, very large. So we've got that. So it'll map this, the whole /16, right? Will get done. There's really no way to, sometimes you can automate it or optimize it. Let me go over here to switch 2. You might be able to type in no auto summary, and you can sometimes make it cleaner. So let me hit the up arrow, do show IP route, and we'll wait for the next round of routes to come through. Okay, that's better. So typing in no auto summary does give us a little bit more flexibility, and you're going to see how this route comes through. It's a more specific route. So you'll see the routes showing up, and then after, you notice how this one, the timer's going up 42 seconds. That will continue to climb until it ages itself out at the 240 seconds or 4 minutes, because we gave it a more specific route. So that's how that comes into play. So you can do auto summarization if you want to. So I'm going to type in no auto summary on these guys here, router RIP, no auto summary, and then switch 1 as well, router RIP, no auto summary, so on and so forth. Okay, so now that we've got that taken care of, we can start to see some filtering of routes and stuff like that. So that's essentially what we'll need to do. So for every SVI or every VLAN that we have created here, we're going to have to do the exact same thing. Now, can you take like a 172.31.5 and then summarize it? So sometimes you can. So if you were to come in here underneath the, you can auto summarize to the network, but there's really no way to do like a summary. So the way so address family, IPv4, unicast, I don't remember there being a way to do a summary. Yeah, as far as I know, you can't do a summary here. You can do a, you might be able to go, let's see, I'm on R21, you might be able to go to gig 0, might be on switch 1. We can try that at the interface level. So interface gig 1/0. And we type in IP RIP and advertise. Yeah, you can't do a summary like you can with EIGRP, because if I was to type in IP EIGRP, or is it IP summary address? I take that back. Yes, you can. Summary address, we'll type in 172.31. We'll do 172.31.5.0. What the mask is going to be a /22. 22, so 254/23. This will be a 248. 248.0, and hit the enter key. And so R21 should receive that in. If I do show IP route, we should start to see a network come through. And you notice here we've got this guy right here. This is it's flushing the route. So I am waiting for the next routing update to come through to see if I'll get a /22 to come through. I don't know if it's going to or not. Oh, you know why? Because, well, I should. I'm hopeful. 172. Yeah, see, it's not triggering. Oh, you know why? I know why it's not working. Because I used the wrong mask. Switch 1. Take this back. No. We'll go back here. So I want to do a 172.31. So I have my mask is wrong. So it'd be 0.22 be 0.4. That's why. Let's do a 4. Even though this one technically is what it needs to be. I'll do a 4. See if that makes a difference. Let's go back to router 21. I don't know if that's actually going to trigger. We'll wait for the 30-second timer to time out. Yeah, it's not. Okay. Not that big of a deal. I'm not too terribly concerned with that. I would have to adjust my math. 22. Actually, no, that's not right. 22. 1, 2. 1, 2. Yeah, I'm using too many subnets. So the LAN subnet should be pulled in. So it would be 0, 1, 2, 3, then 4, 5, 6, 7. Yeah. So this technically would be correct. I don't know why it's not showing up. Okay, so yeah, let's see, it's not coming across. Not exactly sure. Like again, this is not one of those things where I'm like super concerned about making sure that the summarization works. It's just one of those things where it's more of an on-the-fly test. But as you can see, with the capability, you can try to optimize RIP a little bit, but the reality of it is nobody really tries to optimize RIP. So that is the case there. So I'm not going to waste any more time trying to monkey around with that. What I will do is we'll go through and get the remaining subnets in another video. I won't waste any more of your time trying to get that configured. I'll just do the exact same thing. I've got the subnets in here. So what's cool is if we go back to switch 1, for example, and we do show, let me go ahead and pull this guy out here. Do show run section RIP. We are, oh, maybe that's why. Hold on a second. Maybe that's why it's not working. Let me go back here. I think I might have just realized why things aren't working. So router RIP, network of 172.31.0.0. Wonder if that would help. Maybe. Cross my fingers, hope to die. Oh, I don't want to die. Aha, there we go. /20. Okay, so I was wrong. So 22. Never mind, figured it out. That's a /21. So my subnetting skills are a little rusty. Let's go back to switch 1. Interface gig 1/0, and we're gonna do. We'll copy and paste this one back in. 248. 254 is what I want. Right? /21. 254. That's a /23. 248. Yeah, because if I do this, I go back to the R21, that's going to come back as a /23. I want a /22. Because a /23 is 2 /24s. A /22 is 4 /24. So I need 1, 2, 3, 1, 2, 3, 4. So I actually need 1, 2, 3, 4, 5. So I need, yeah, I need a /21. So, okay, so that's, okay. Let me go back over here to switch 1, and we're going to go to here, type in no summary, and we'll come back in, we'll type this in, go to the end of the line here, we'll do 248, because that will encompass everything. Because if you're doing those in the correct ranges, well, technically 248 would be, technically that's an 8, because it's /21, so this actually needs to be an 8. So, because 8 won't work, so this should be an 8. So let's go back over here to R21, hit the up arrow, and we're waiting for the next cycle of rest to come through. Once that does, we should see a /21 come through. So that'll be the caveat. But anyway, the point being here is that if you wanted to summarize, you could. You just have to figure out what your subnetting is going to be. Clearly, I'm probably putting a little too much effort into it, but my math is wrong. So it's classful, so why is that not coming through now? Anyway, not that important. I'm not terribly concerned that it's not working. If you guys want to stick some cycles into it, feel free to do so. Let me go back to the 4 because the 4 seems to be working. Let's do show run interface gig 1/0 and pull this summary route out. Oh, I see what it's doing. The summary route I don't want there. So let's go back over here to R21, hit the up arrow. So in reality, I would need to figure that, whatever that math is, I need to figure out what the binary math is in order to make it work. But as you can see, it was coming through for a little bit there, but at the end of the day, it's not terribly important right now for the purposes of this video. But those are the capabilities. So we've got RIP running, we've got the neighbors formed, or adjacencies formed, I should say. We also have a default route propagated, so our switches are learning a default route. If we go over here and we look at the show IP route, we can see what's coming through. And we had a default route from 2 different next hops, which is exactly what we're looking for. So everything looks like it's doing what we want it to do. So that, ladies and gentlemen, I was going to do 3 videos on RIP, got it down to 1. So that much less stuff for you to worry about. So I'm happy with what I've covered so far. RIP is deployed, and we're in good shape. If you guys have any questions, please leave it in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine folks in the next video.